ছিল। এরপরে আজকে আমরা তাহলে কি করব, আজকে আমরা এর পরের নিয়ম ধরবো। এই দুটা ম্যাথ আমরা আজকে শুরু করব। তোমরা সবাই রেডি হও। রুল নাম্বার 3 এর আন্ডারে অক্টাল টু বাইনারি এন্ড হেক্সাডেসিমাল টু বাইনারি। আমি শুরু করি। রুল নাম্বার 3 করা শুরু করি। ফার্স্ট অক্টাল টু বাইনারি। দেখো octale used symbol. What are the symbol used in octal number system? We already know it. That is from 0 to 7. Can you count how many number used in octal number system? How many digit? 8. So the base of octal is 8. Okay, if I draw a box which is 3-bit box like this, first one is 2 to the power 0, 2 to the power 1, 2 to the power 2. So this is 1, 2 to the power 1, that is 2, 2 to the power 2, that is 4. So by using this box, I can express any value between 0 to 7. How? If you want to express 7, you can put 1, 1, 1. Can you add all the numbers which is those are indicated by 1? 4, that is indicated by 1. 2, that is also indicated by 1. 1, that is also indicated by 1. So can you add 4 plus 2 plus 1? The result should be 7. So I can express 7 by using this 3-bit box. What will happen if I want to express other digit like 3? If you want to express 3, what will be your procedure? How can you express 3 by using this 3-bit box? 2 is, I have selected 2 indicating 1, and 1 is also I have selected, and this is 0. So what will happen if I add these values? 2 plus 1, what is it? 2 plus 1, 3. So I get 3 here. Now again, so I can, how can you count 6 by this box? Can you count 6 by this 3-bit box? How it's possible? Anyone?
4 plus 2.
The value of 1 that should be submitted to, I will ignore this value, that is 0. So 4 plus 2, that will calculate 6. So by using this 3-bit box, I can express any value from 0 to 7, and for octal 0 to 7 is enough. So can you convert this 75 into binary from octal by using this 3-bit box? 75, you can use this 3-bit box. 1, 2, 4. 7 means all 1. How can you count 5?
4 plus 1.
And 1,
plus 1.
5. 4 plus 1. So 1, 0, 1. This is 5. The final result, what should be the final result? Okay. Can you solve this one? 6, 7, 3, 8. Okay. Calculate this figure into, convert this number, octal number, into binary number, and compare the result with my answer. I have already started. Seven.
Sir, done.
And what about 3 and 4? Done. So can you compare the result, final result with me? Is it correct? Is it same? It is. Have you compared with my result with your result?
Yes, sir.
Okay. So then you can complete another one, and can you see there is a floating point here in this number? Can you see it? 105.24.
Yes, sir.
So be aware of it. Of course, you will convert it like this, but don't forget about the float. Showing you the result. If you disagree, then you can also show it by your messenger group. Here is the result. Don't forget about the fraction point. Be careful, it is important. I mean, there will be a fraction point. Have you seen it? Fraction point.
Yes, sir.
Okay. So how many bits you need to express any octal number? If you want to convert it into binary, how many bits do you need for each digit?
Three.
Oh, okay, 3. Yes, 3 bit. You need 3 bit. Why 3 bit? Because by using 3 bit, you can express any digit from 0 to 7, and from 0 to 7, converting from 0 to 7 is enough for octal number, because we have already know that any octal number that should be consist of 0 to 7. Okay, now we will go next step, hexa number. But 3 bit is not sufficient for hexa number. Why? Because in hexadecimal number system, you need 16 symbols. Can you see it? 16 symbols. So you need more bit. You need 4 bit. If you press all one into the box, what is the summation of all one?
Sir, 15.
It is 15. 15. What is the largest value of hexa number? F. And
16.
F is equivalent to 15. No,
Sir, 16.
from 0 to F, you can count, it will be 16, but the value of F is 15. 0 to 15, if you count 0 to 15 or 0 to F, it will be 16. But the value of F is 15. So, for converting any hexadecimal number to binary number system, you need 4-bit box. Okay, now try to solve an example. Hexadecimal to binary, write down the headline and try to convert this hexa number into binary number. Okay, I have already started. You need to write 4-bit box. How? Like this. 1, 2, 4, 8. Starting it again. You can match with my result. Okay, next problem. I will give you next problem that is also containing a floating point. B0C 0.19. Be careful. There is a fraction value. Have you seen it? The fraction value 0.19. Don't forget about it. Okay, here we see the result. Have you matched it with my result?
Yes, sir.
Don't forget about the fraction point.
Yes, sir.
Here is the fraction point. Okay, তাহলে next আমরা দেখি যে another rule, that is binary to octal. Okay, what you know about binary and octal? How many digits? What is the relation between binary to octal and octal to binary? How many bit you need? We already know from octal to binary we need 3 bit. So the relation between octal and binary we can express it by using 3 bit. So 3 bit box will be required. What about binary to hexa? How many bit you need for hexa to binary or binary to hexa relationship?
4 bit.
4 bit. So we already know it, the relationship between binary to octal and binary to hexa, hexa to binary, octal to binary, we know it. Now I am converting a binary number into octal number, so I need a 3 bit box. So example, as for example 11101, write down the example. Okay, how many bit you find in this digit?
5.
5 bit. But we know that the relationship between octal and binary 3 bit. So how can I make it 3 bit combination? I have added a 0 at the leftmost side. Now how many bit is available in binary number system?
So now 3.
6. After adding an extra 0 in the leftmost side, so 3 bit. So how many bit total?
6.
So if I add an extra 0 at the leftmost part, is there any change of the value of this number?
No, sir.
Okay, so if I put a 0 at the leftmost part, so no change will happen, but still I have managed it to divide this bit in 3 bit all. Dekho, 3 bit. All of these are 3 bits. Now if you place this digit here 101 and add, keep the value where there are 1 and ignore the value where the value is 0. So what are accepted here?
3.
Where the 1, 4 and 1. So the summation is 5. So the first one, that is 5. What is about the next one? 011, 011. So what is the value?
3.
Very good. Only very good. You are very intelligent. Thank you. So result is 35. That is in octal. So now it's time to exercise more. Here is another example. How many bits there are? 1, 2, 3. 1, 2, 3. So how many 0 you need to put left side of this?
2.
Yes, you get it. Okay, so you can easily convert it by 3 bit. That is how many digits there are? So this is the math in suitable form. Now if you use 3 bit box for this one, this is 1, this is 3, this is 1. So 131, the result is 131. Okay, now another exercise that is consist of also fraction point. If there are fraction point, what can you do? If you want to make 3 bit, so you need to add some extra 0 at the right side after the fraction point. here is the fraction point. So I have added a 0 here and I have added 2 0 on the left side.
42.
Okay, I am seeing 167.42. Very good. Anyone else want to match his or her result with me? If have any confusion or his or her, if the result is not same to same as with mine, then you can ask me or you can show me in the group. Or if you don't want to show it in group, you can also inbox me. Okay, another rule is completed. Now I will show you binary to hexa. What are the relation between binary and hexa? How many bit you need for binary to hexa? 3 bit?
4.
4.
No, 4 bits. So you need to draw a box that is 4-bit box. Then try to match all these 0, 1, divide this 0 by 4 bit. And if it is required, you can press some 0 at the leftmost part. Okay, try it.
C.
Result is 3C. Yes. Although I see there is 12, but 12 will be not accepted. Because in hexadecimal number, 12 will be expressed as C. Now we will try another problem. Try it. And there is a fraction point. Okay. The result is 7 D.FE. Is it okay? Or do you
Yes,
have any
sir.
other opinion? Okay. So from the beginning of today's class, we have discussed about 4 rules. Octal to binary, that is divided a number into 3 bit. Hexa to binary, 4 bit. Binary to octal, and now binary to hexa. So we have already completed 4 rules, but now I am going to show you another rules, that is hexa to octal and octal to hexa. But there are good news, because you don't need to learn any new technique. You already know the previous 10 rules, and today for last few minutes we have discussed 4 rules, and you just need to combine these 4 rules for these 2 new rules. How? Write down this. Okay. Now hexa to octal. You cannot convert hexa number into octal number directly. You need to convert it to binary first. How can you convert from hexa to binary? Do you know it? Have we already learned it? How to convert hexa to binary? Yes.
Yes, sir.
4 bit. And if you arrived at the point of binary, then you can convert it into octal easily. How? You already know binary to octal number system. Here is the process. Binary to octal number. By adding 3 bit And but at the first stage you have converted hexa to binary, then binary to octal. So ultimately you have reached from hexa to octal. So octal result 253.632. This is the result in octal. Now I will show you how to convert from octal to hexa. Similar technique. First, you need to convert it octal to binary. How can you convert octal to binary? Today we have discussed it, details about it. If you convert it binary number, then you can go anywhere. From binary to this hexa is very easy by adding 4 bits. So I have converted this octal number into binary number using 3-bit box. Here is the binary conversion from octal to binary. Then I use another technique that will convert, that convert binary to hexa.